Hello everyone. Imagine this. 59 million people watching same cricket match at the same time. One small mistake and entire country starts tweeting Hotstar down. This is not a hypothetical condition. This is a real story of Disney Plus Hotstar, one of the largest OTT platforms in India serving live sports to millions. Before 2023 ODI World Cup, Hotstar had already hit 25 million concurrent streams by using just two Kubernetes clusters. That alone was insane. But then things changed. For Asia Cup World Cup 2023, Hotstar launched free on mobile. Yes, this Rockefeller kind of things, giving free on mobile content to millions of users with Jio internet at their hand. There was no paywall, no friction. Any country that's obsessed with cricket can watch the content. 50 to 59 millions of concurrent streams, a scale no one in the industry had ever handled before. So, this kind of juggernaut statement can come with its own caveats. So let's understand here, how will you handle a live 59 million concurrent stream load on your app, whether you will be fortunate enough to handle this much load. That's another point of discussion. Like here we will understand if if like your app gets 59 million concurrent streams, what issue you can get in your EKS clusters and how you should handle it like the Hotstar did. So let's proceed. During one of their load tests, Hotstar faced one issue in which their NAT gateway was using up 50% of its capacity while the peak load was only 1 by 10th of its value. So if peak load was increased few amounts above that, NAT gateway would have choked, like it would have reached its limits. How they were able to know it? They had enabled VPC flow logs on the NAT gateway ENI, and by analyzing VPC flow logs, they were able to know that their NAT gateway capacity is reaching 50% for each availability zone, even with only 1 by 10th amount of peak traffic. So in real system you face these kind of issues. Like if you deploy a small project with few availability zone with some subnets, you will never face this kind of issue that your NAT gateway outbound throughput is near exceeding. But in real world, if you are fortunate enough to have your app to serve 50 million users concurrently, you will face issues like this. So how Hotstar were able to handle it? So as per the official statement, we scaled out NAT gateway in subnet level instead of availability zone level. So they went by breaking the orthodox of keeping NAT gateway per availability zone only. Rather, they moved and placed NAT gateway in each of their subnets so that each of their subnet will have an outbound window for their own. And when they tested it with the peak traffic simulation, then these each NAT gateway in one subnet for particularly cater to it, this particular setting worked just fine. After testing out NAT gateway during their load test, they moved their attention towards their Kubernetes worker node. During load test, they found some of their Kubernetes worker node throughput was going well beyond 8 to 9 GB per second, which was not suitable for their service to work at the production conditions. Like here you can see the Grafana screenshot of their actual Kubernetes worker node throughput usage. Here receiver and transfer traffic for Ethernet interface, you can see here lots of Kubernetes worker nodes throughput is going well beyond 8 to 9 GB per second. So to solve this particular issue, what they have done is they have replaced their nodes having network throughput of 10 GB per second, and also they have fixed single pod on each node for a service for which throughput was exceeding. By fixing single pod on each node, the throughput of 2 to 3 GB per second was achieved even during peak traffic, and that too you can see for very small interval of time. Let's see another problem Hotstar faced while working through their Kubernetes clusters. Shortage of IP addresses. They had to serve 50 million users nationwide for World Cup 2023. But suddenly they saw one problem, that their Kubernetes infra were not able to scale up pods above 350. Like they were not able to scale pods larger than 350 in number. Although they had 4090 IP addresses per subnet, and for 3 subnet, 12,300 total IP addresses. So let's see why their pod numbers were not able to scale above 350. In their VPC CNI setting, they have minimum IP target set to 35, warm IP target set to 10. So what exactly is VPC CNI? VPC CNI is an add-on to Kubernetes cluster in case of AWS. This provides IP address to your pod running in Kubernetes cluster. It has one setting called minimum IP target, which keeps a particular amount of IP addresses reserved in a particular node, so that in case that particular node need more pods, that pod IP addresses can be taken from this minimum IP target. Apart from that, it also has one setting, warm IP target, which keeps X amount of IPs in warm standby so that it may be needed within a node. So if we calculate here, 12,300 IP addresses if divided by 35 IP addresses reserved on each node correspond to 350 nodes only, and they had scale up need for above 400 pods. So how they were able to like solve it? Like one solution can be increasing the IP addresses here. Another solution can be decreasing the minimum IP addresses on each particular node, because in their nodes, not all the nodes actually need 35 pods anyway. So they actually solve this problem in both the dimensions. This started using /18 cider block, which made total IP addresses equals to 49,000 in all three, with all three subnets IP address counted, and they set minimum IP target to 20, warm IP target to 5, because of which 49,000 divided by 20 IP addresses per node gave them 2,000 plus IP addresses available. So by this, they were able to scale without any issue above 400 pods for a given scale up. Even with warm IP target of 5 per node, these settings provided IPs for scale ups and with 40% IP utilization throughout World Cup 2023. So here we saw, if we want to design our backend system to serve 50 million users, we will run into problems like this. Like their Hotstar were not able to scale their pods beyond 350. Why? Despite having IP address pair, this minimum IP target limit was blocking them to scale their pods beyond 350. And during a real production traffic spikes, these kind of issue can make and break your system. So if we deploy EKS for our smaller RPS API or backend task, we may never face this kind of conditions. But Hotstar has done rigorous testing and real-time load test simulation, which makes them understand that if their service need to scale up beyond 350 pods, it will not happen right away with slash 20 cider block and 35 node minimum IP target limit per node. So by rigorous testing, load testing, they were able to deduce they actually need slash 18 cider block with 49,000 IPs in all three subnets and with minimum IP target of 20 and warm IP target of 5. These kind of parameters are fine-tuned to your system with its particular use cases. There is no hard and fast rule for these kind of parameters. You have to do simulation, you have to do load testing, only then you will be able to know what are the optimal parameter for your system to work under real production load. Now on this particular issue of Hotstar, we will see a very good use case of vertical scaling. Like always, you have studied that vertical scaling is a lame option. You always do horizontal scaling. It's more viable than the vertical one and less costly. But here in this case, vertical scaling was the best option. So let's see what was happening. Kubernetes endpoint API was unable to scale beyond 1000 endpoints, which means it was unable to scale pods beyond 1000 in number. So if your service needs beyond 1000 pods, then how will you approach that particular problem statement? Like their EKS cluster, which needed more than 1000 pods, they had to do vertical scaling for those pods and cap a limit of 1000 pods for that particular EKS service, because Kubernetes endpoint API was not behaving properly above 1000 endpoints. So that was an amazing discussion of Hotstar backend architecture. Without getting a chance to work there and actually handle 59 million concurrent users yourself, like we are fortunate enough that they have released their engineering blog. That link is provided in the description, you can check that out. And by that we were able to know the real backend problems in real-time production traffic. So if you like this video, please subscribe, like, comment, and show some love. That motivates me to create that kind of content again. So that's all for today. Thank you.